Hello out there. For those of you familiar with this channel, you'll know that I tinker with lots of shingle mills. So accordingly, I managed to find a pretty uncommon machine. This is a saw gumming or saw sharpening machine, and it's specifically adapted to bigger blades like crosscut saws and shingle mills. This thing is made by the Samuel C. Rogers Company, and he was a Canadian, a Hamilton fellow, and he went down to Buffalo, New York, and accordingly called these machines, of which he had a line of three, size number 1, 2, which I don't have, and number 3. And he called them the Buffalo saw sharpeners. So going back to 1889, there's an available catalog on vintagemachinery.org, wonderful website, and it shows this exact machine. There are a couple things missing from this linkage-wise. There should be a handle to advance the blade so that you can kind of use the next tooth as a stop. But anyway, I think we'll be able to make do without. That's why that thing's here, is to kind of show a couple of the missing parts. These machines were offered in manual operation, which this one is, semi-automatic, which I haven't quite understood yet, and fully automatic. That's an automatic machine. So you have the drive pulley. Originally would have been a tight and loose flat belt pulley like that one. This one's been electrically converted. You know, someday it'll go back to line shaft, but that's perfect for using it right now. There's the little counter shaft on the bottom here with the big pulley that goes to the small pulley to run the grinding wheel. For the automatic machines, there was a worm gear and then a worm wheel that went up to a vertical shaft and a cam which would actuate the grinding mechanism and also advance the blade, which would be the hot setup for industrial production or big mills or whatever. But a manual operation is perfectly fine for us. Gives you a little bit more time to do fine tuning as well. This specific machine, the number 3, was sold to go from 8 to 72-inch diameter blades. This one here is hair over 36. This also you can see is rusty. It's in rough shape. This is a spare shingle blade that came with our Lloyd automatic mill. So I'm going to use it as the dummy, crash test dummy. I'll kind of zoom in here. This one was likely hand filed for many, many years. And the gums, or the gullets, are pretty funky shape, kind of from the edge of the file that they used from kind of rubbing on it. Ideally, a blade has a rounded gum, which reduces the likelihood of the formation of cracks. Because if you have a sharp point in the gum, we call that a stress riser. That's where a crack can kind of originate from and move throughout the blade. These shingle blades aren't really the most likely to blow apart from a crack, but they do often lose teeth from similar reasons. This one here has an exploded tooth right there. They don't tend to explode because you have, on top of the central nut, you have a whole bunch of other mounting points to the cast iron mandrel, bell, splitter, whatever you want to call it. So that's the dummy, as I said. In order to go from small blades to big blades, this whole arm spins around, which also gives you a different orientation with respect to the cutter, which is stationary. I mean, it goes in and out, but you can't really adjust this. And this whole arm extends as well. Now, this machine came from the McClellan family. Al had this in his shop. I don't think it was ever used. You might recognize that name from last video on the axe handle lathe. I don't think it was used because of how it was painted. There was paint kind of all over the surface of everything. The sliding surfaces were painted over, kind of implying that it was fixed, and it just kind of stayed like that. The pivot bolt was seized, so that would only really let you use one set size of blade. Maybe that's what he did with it. I don't know. Anyway, it's good to go. Behind this, there's an electric motor sitting on the platform under there. I've put some oil in these guys. All these little pieces and stuff that moves and spins and whatever, I've touched with the sandpaper wheel on an angle grinder. You gotta be careful with that because it does love to gouge, especially cast iron. It'll eat it up quick, but it's made some lovely smooth surfaces, and I've just run some oil over it. So you might think, okay, that's all well and good for gumming, doing a straight cut when this blade is flat across, but what about the alternating angles of a crosscut saw or whatever? Well, there's this fancy little contraption on the pivot post. You pull the whole thing back, or you might need to take the screw all the way off. And there are 5 positions. So you just back it up, go to the other position of tilt, or go to the absolute position of tilt, and you can do that on both sides. So then you can grind every second tooth, or sharpen every second tooth, and then back the other way, sharpen every second tooth. In practice, I haven't tried this machine yet. You're about to see me try it, and I guess we'll see what happens together. So let me put this blade on and we'll try and tweak it, see how it goes. So this is the centering device. You can use the inside for smaller diameter holes or the outside for larger. That. Now, this is the little cryptic castle nut, I guess you could call it, that has different steps for different depths. There we go. Get the rag out of the way. I'll just tap that wedge in. There we go. Now, to set the orientation. Oh, I suppose I should tighten it in the flat position as well. So as I said, I've never run this machine before, but just kind of going the old common sense route. This little thing here, I think, is just to support the rim. The blade will kind of go on top. I might raise that a little bit, make everything plainer. So, I'm happy with that. The angles are all quite different. This tooth here, for example, is almost in line with the center, and these teeth here are much more aggressive. So once we lock the center in position, this angle will be made consistent. Yeah, I'm happy with that. So, yeah, that bottom rest should come up about 1/16 of an inch to support the blade. I'll go ahead and tighten the in and out feed. And then there's a jam nut here and a screw that will set the depth. So the first tooth that I cut, I'll just kind of go by feel, see how deep we should go, and then I'll set the depth so that it's consistent. The grinding wheel that's on here is just a standard 1/4 inch emery wheel, what they reference anyway, and it's been kind of rounded. I assume these days the rounded wheels, I don't know how available they are, but you should be able to get a standard 1/4 inch wheel and just use a diamond dresser and kind of round the edges. Fire up. Good measure, tie a little bit of oil all the time. Also, the far bearing, you might be able to see, has been replaced with a roller bearing, greased roller bearing. The top shaft is still Babbitt, and this bottom one is as well. I must say, even in the original design, the old fingers are a little bit close to both the belt and the wheel. But that's okay, we'll make do. That's about good for depth. Oh, got a long way to go. There we go. Put the jam nut. Oh, it's a little bit of inconsistency. I'll have to go a little bit deeper. I must say, I'm at a little bit of a divide here. So typically you don't wear gloves anywhere near belts, of course, because, for example, this hand, if it snags the belt, or technically any jewelry either, it can grab and it can pull something of you into there. But I'm also spinning this blade, so I think I'll do a halfer. Do one of these. I don't want to get poked by the blade and don't want to get grabbed by the belt, so we'll do this. Looks great so far. Looks very nice. There's a major inconsistency. That depth will go all the way through any file remaining marks, like the one that was just cut. And the first one, it barely even touched on those marks. So I'm going to do the whole thing with this depth now, because I think the depth from gum to tooth is plenty. I don't particularly want to go deeper than that. But yeah, I'll give you some close-ups here. Well, I just tightened the stone. It decided to get loose, and now I figure it's a perfect time to try Jonas Kupfer's belt dressing. This is a Mennonite belt dressing from down south of here. It sounds like the actual V-belt is slipping. Oh yeah, it's darn loose. Well, I guess I'll have to slide the motor, but maybe for fun we'll try this on that as well. The picture shows a V-belt, but I'm sure this is good for flat belts too. Contains cylinder oil, neat's foot oil, compound, and resin. Quite thick, as would be expected. Often this stuff needs a few minutes to kind of start to get tacky and actually work. And then of course we'll need some for the flat belt. How can I put that on there? I'll just put it on the pulley. Ah, better already. My. Can you hear that? The belt is really grabbing now. Reference blades. This one is off of the Lloyd automatic mill. You can see how shallow the gums are. We've tried it like this for fun, and they just plug up right away before they get out of the block, and the whole thing seizes up. So that's no good. But you can see the grind, which was done by a professional shop. Pardon me. It goes right to the tip, and then it's the surfaces, the outer edges that are ground on angles or filed on angles. So we have left, left, right, right type thing. If we go to this other old blade, which I've never touched, you can see the same thing. Deeper gums, of course, that's why I picked it up, which are straight, and then you have alternate angles on the teeth. And the teeth in this case are also swaged significantly. You can see the little swaged or bent, whatever you want to call it. The tips are alternating, kind of hammered offset as well. Well, now what's going on here, you might ask? Well, I took that little pivot thing and twisted the blade, and then sat here or stood here a while and pondered, pushed it in and out, flipped the whole top piece around. How the heck am I going to do this? Well, I realized this machine isn't meant to do what I had in my head. This configuration is meant to do crosscut saws. So if I was lined up with a tooth here, I could do a pass every second tooth and get them alternating like I mentioned before. The way that these saws, that this saw and a couple of the others have been sharpened in the past, is to kind of alternatingly cut the outside of these teeth, this is really a ripping saw. So 2 and 2 really isn't adding up here. Anyway, I figured I'd keep it in this configuration because it looks kind of cool, and we'll do a simple operation. I'm not sure what it's called on circular saws, but for crosscut, 2-man crosscut saws, the process is called jointing, and it's kind of what you do the first thing before you sharpen. The position of the saw for this is kind of arbitrary, it doesn't really matter. What I'm going to do is line up a given tooth with the wheel, just so it barely touches, and then I'll set the jam nut here, and I'll hold the wheel forward, and we'll just spin the saw, making sure that this is tight and it's going to be perfectly concentric. The orientation doesn't matter as long as it's concentric. I'll spin it, and this is going to tell me how far out the saw has become with years of filing. So we'll probably have one point which is higher and the other point which is lower, so that won't touch the grinder, and this side will. This is theoretical, I haven't done it yet, so let's see here what happens. Nothing, nothing, nothing. Whoa. Obviously started on a high spot. I'll move it in a little bit. There we are, back to the start. So you can see that the result of years and years of hand filing has left the whole circle a little bit oblong. That's the benefit if you were to use a sharpening machine consistently. The teeth tips would be at the same distance from the center, and you'd get a much smoother resulting shingle. You might have seen, well, you would have seen shingles out there with all kinds of ridges. Sometimes they have gaps. A saw like this with a broken tooth, that would result in a big gap, smooth, 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 gap, smooth, smooth, of course. And then the variation of the set would result in a different kind of surface rippliness. So I guess I probably should have done that first, kind of jointed the saw and then gone from there. Looking at that good blade over there, I believe what they did was sharpened everything square like a ripping saw, and then they took a saw set and cranked each alternating so that the body of the blade wouldn't rub. You're always taking a wider cut. So that might be the best thing to do with this. I'll reorient it and grind the tops flat. So I'll lay it back down and then take those funky angles out of the tops and just do that approximately. Set the depth and then kind of make a little bit of a radius on them. Well, there we go. First trial run of this antique gumming machine. Definitely got lots more learning to do. Going to reach out to a local sharpening specialist and do some more pondering, some more thoughts and prayers before finally trying to sharpen the real automatic mill blade. So this one, like I said, just an experiment, not going to run her, but maybe down the line, once I go over it again, get confidence for the other one, then I'll show you the Lloyd mill running and we'll actually power it up with the John Deere or something. So hope you enjoyed and see you next time.